benimle. Hello bro, do you hear me?
Yeah, I can hear you. Everything's fine.
Aa, chat, Hussam'ın sesini duyuyor musunuz?
Test, test,
Keep talking man. Read your
test,
presentation title.
test, test. Just wait and then I will tell you why PowerShell is still great. Or it's
Okay, I got
right.
a confirmation from the chat. Your voice is loud and clear, and thank you very much for being here for the second time. And all of your presentation always been wonderful from the technical side. And
Thank you.
today you are with us with PowerShell related stuff. So if you are ready, everyone on the chat and I ready to go, man.
Okay, good morning, everyone. Today we'll talk about some stuff about PowerShell. Just wait and I will tell you why PowerShell is great. So, some about me. My name is Hossam, and probably people having some issues with the name. So anything starting with H and ending with M with S in the middle is totally fine. What I'm doing is I'm security case officer at CyberStruggle, and security case officer might be a bit different term. Basically, it's a guy who gets the job done in terms of infrastructure, security researching, developing tools, content labs, and so on. So a little bit about my background. I'm a developer, pen tester, red teamer, security researcher. You might hear or attended some talks or workshops from me as a developer or security researcher. Today, I'm here as a red teamer. So the agenda is making PowerShell great again. Well, it's already great, but I'm here today maybe just to spread the word. By end of this talk, if you are a pen tester or red teamer, you will understand more about PowerShell internals, and with some research, your next engagement, you will be able to rely more on PowerShell as a attack platform. We'll talk about PowerShell in enterprise environment, what kind of mitigations they are applying out there. Then we'll take a look how we can work around these mitigations and bypass them. And we will know the actual fileless or in-memory PowerShell attacks, blow up some shells, of course, bypass some EDRs and some security products. As I said, it's already great attack platform. If you are into adversary emulation business, you might be aware of a lot of techniques that adversaries already using and operating with it in different operation pages, like privilege escalation, even writing Active Directory exploits or Windows exploits itself using PowerShell. Since it's a scripting language interacting with COM object, Windows APIs, and WMI, it's really powerful attack platform. It's open source, cross-platform, dealing with structured data. Imagine a scripting language dealing with structured data. Whatever you're sending back from your C2 server, maybe JSON data or XML, it can just parse them and handling, decryption and encryption process real easy. Also, you can spend some time looking at the PowerShell source code and try to find different bypass or tricks that might bypass the security products, and somehow you can abuse the features of PowerShell and built-in functions. And this is what we are going to dig in right here today. We'll try to understand how things working underneath the hood and try to understand PowerShell internals. So, but unfortunately, there's not that much great in enterprise organization. We got restricted and constrained endpoints. So we got script block logging. We got even disabled PowerShell. Some enterprise just disabling PowerShell. We got AMSI interface and a lot of other issues we need to deal with in enterprise networks. So basically, we are here today just to hack all of them, but the point is we are not just going to copy paste some payloads. We will really understand how this payload is working and how people who found this payload or invented this payload understood how these things work within PowerShell. So you can also go on your own, look for some bypasses, use them, and that's it. So let's start with constraint endpoints. First thing we hit in any environment is constraint endpoints. basically it's POLP implementation in PowerShell, and POLP is more like an information security term. We don't need to know about it right now. Anyway, it's basically restrict access to sensitive elements of PowerShells that could be used to execute some bad or malicious code, such as calling Windows APIs or .NET APIs could be used for malicious purpose. And as we see in the photo, in the slide, we got execution context, which we're gonna see in the moment, and the language mode in the session state is set to constraint languages. We are trying to call a .NET method, as we see, red exception, and I really hate red colors in PowerShell specifically. So more about execution context. Execution for each execution context, to be more specific, for each PowerShell instance, we got execution context, and for each execution context, we got a session, and for each session, we got a language mode. So we got 4 language mode. We got full language, restricted one, low language, and constrained language mode. In this talk, we'll just focus on restricted and constrained language mode, because basically full language mode means you're just free to go. You can do whatever you want with PowerShell. So it's not a problem. The problem is with restricted language and constrained language. And in PowerShell source code itself, by the way, it's written in .NET C#. You will see such switch cases, a lot of it. Like, for example, if the case is restricted language mode, performs that specific action. If it's full language mode, performs that one. If it's constrained, performs that one. As we see here, restricted language mode is performing some type of a static check for the code, like parsing the code, perform some checks, and constrained one is checked during runtime. So let's talk about constrained language bypasses and restricted one as well. Both of them almost the same. There's just one additional bypass we will talk about in restricted language, but all bypass working with constrained one can just work perfectly with the restricted language mode. So first thing we are gonna abuse is weak implementations, because basically some system administrators are, just Googling stuff and trying to find the easiest solution, which require the least configuration, so they won't spend too much time on the job. So basically, he will just set this machine environment variable to 4 and apply it by a group policy. Because this is what's common in system administrator forms and helping websites, etc. If you want to secure PowerShell, you can just set this machine environment key to 4, which indicates that you will during instance initialization in PowerShell, as we see in the photo, it will check for that value, and if it's on, it will just set your language mode to constraint language mode. Basically, this is a weak implementation, because if you got a local admin, you can just change this machine environment variable and start new PowerShell instance, and you will just land into full language mode access, as you see right here. Okay, like we are renting the execution context language mode and its constraint. Then we are setting as environment variable by interacting with the registry keys, setting it to 8 and launching new PowerShell instance, and we got full language mode. So also we got downgrade attacks. Since constrained languages or constraint endpoints introduced in PowerShell version 3, if you just launch a PowerShell version 2, it will work, because PowerShell version 2 doesn't know what constraint endpoints mean. So you can just launch PowerShell version 2 and you got full language access as well. So easy. So we got really problem right now, because we are in an environment where we got PowerShell version 2 is installed, we got app locker, no local admin access, and it might be a bit challenging or something like that, but you are red teamers. We are here red teamers, so no problem. So we're gonna change some attacks right here. we'll bypass AppLocker and launch PowerShell in full language mode. And how this can be done? This can be done by the following. If you remember about, or if you are familiar with AppLocker bypass method, one of the most common one is executing .NET code through MS build. Like you are crafting the .NET code as a task, an XML file, and just starting it. As we mentioned, that PowerShell is written in .NET and it's generating, like, there is exported DLL, which is system automation. You can just call some functions from that DLL and start your own PowerShell instance. With the default configuration, without nothing special, you can launch or start a new PowerShell instance in full language mode. No magic right here. Okay, so you bypass AppLocker in case that PowerShell is disabled, and as well you got full language mode PowerShell. Okay, so you can run your bar up or bar view or whatever you want to run PowerShell right now, no problems. So everything's applied to restricted endpoints as well. Like right here, we are setting the language mode to restricted endpoints, but we are trying even to interacting with the variable itself. It's giving us, you're restricted to deal with that type of data. Okay, if we just run the same file, it will bypass all of that and we will land into full language mode. It's really easy. So also, like downgrading attack working with restricted endpoints. And restricted endpoints can be bypassed also with shellscape, by escaping the shell thread, like using invoke expression. Like as we see here, you are just invoking expression and passing a native .NET call, and it's working, which means you can execute call in full language mode. So that's all about restricted endpoints. So another big issue is script block logging, and script block logging is a really big headache for red teamers, because everything you are executing within the PowerShell engine, and I'm gonna explain what I mean by executing in PowerShell engine, getting logged in a moment. And like starting from invoke expression, obfuscated code, deobfuscated code, because it's logging both of them and it just storing them under event ID in Windows 41004. Okay, so basically it's logging all the scripts you are executing during your red team operations, which is something we don't really want. So as we see here, this is the function responsible about logging in PowerShell. We got at line 16, we got script block logging struct, and getting the log setting, we have a function of get script block logging settings. Okay, and we will check this function later on the struct as well. And as we see here in line 32, like if you try think about overflowing the scripts or sending or providing really large scripts, you're saying, okay, that might overflow the SOC team and they won't see me. Unfortunately, it won't work because your script is getting splitted into smaller chunks and it's get logged as well. Okay, and the bypass trick here is about get script block logging setting function. Okay, because you are trying to control the value returning from that function right here. Okay, so and controlling the script block logging struct right here, which is containing two members. Okay, so we want to set enable script block logging to false if it's true, and this can be done. By the way, as I mentioned, like you can just script block logging, okay, it's working from everywhere in PowerShell. Okay, as I mentioned, or if we can recall a minute ago, I mentioned that anything running with the PowerShell engine, because with MS build method you are interacting with PowerShell engine, so you're still on the radar. Okay, whatever you are using, custom DDL or custom executable, or just MS build tasks or whatever you are using, or interacting with system automation DDL, you are on the radar. Okay. So this is a Newman bypass, and it's really easy. You are just trying to override the group policy settings. Okay. So you are trying to set script block logging to null values or 0 or false. Okay. So whatever you are going to execute after that in the same session, you're out of the game. Okay. No one can see you. You can do whatever you want. Okay, but there is a problem here with that bypass because it's like a bit noisy, like really noisy. Once you do it, like they will know that you are here. You're trying to escape from them, and they will come for you. So another bypass problem is once you launch a new instance of PowerShell, it's gone. Like you are on the radar again. So every time you launch a new PowerShell instance, you need to, write the bypass code again, and you might need to obfuscate it again, and so on. Okay. So, for example, in PowerStager right here, they are embedding the script logging bypass code within the stager. Okay. So whenever you are executing the PowerStager, whatever is getting executed within it, it's like not logged. Okay, and this is like really well-known signature, by the way. I'm not encourage you to use that. Don't include your bypass script block logging bypass code within the within your stager, because it's really bad signature. Okay, another cool trick, really cool trick for script block logging, and this will really confuse blue team. Okay, if you got a local admin in this box, like sometimes we are in red team engagement and we want to take one box as like base box for us, so we can move tools on it, operating from it, starting maybe some light HTTP servers and so we can just do that the following trick, and we can operate like comfortable within that box. And the trick is, instead of stop sending logs, just send them encrypted. Most of the SIEM solutions won't understand, or of course won't parse encrypted logs if they are not supposed to do that, or they are not configured to do that. Protected event logging introduced in Windows 10, so it might be, like some SIEM solutions doesn't alert SOC team like, hey, I can't parse this log because it's encrypted, unless they just configure it. So you need to go and configure it and upload your private key. In terms of private key and public key, it's using cryptographic message syntax, which is using the public key for the host in order to encrypt the event log, and the private key should be on the other side in the same product, so it can decrypt as a protected log and parsing it and starting to pull up some alert. So most of the SIEM solution, as I mentioned, does not check if the log is coming encrypted and hey, it's encrypted. No, they're just setting it for unknown logs section. So you're hidden anymore. You're not on the radar anymore because you're sending encrypted logs. So another headache with PowerShell is the Windows anti-malware scan interface. Most of ADR using MSI DDL or header file. Like, think about they are listening for the events from MSI, like if this script is malicious or not. And MSI is something, let's think about or symbol as scanning strings or buffers or bytes for known signatures. There is nothing fancy right here, and it's really easy to bypass. And since the ADRs are interacting with MSI in terms of reporting and notifications, etc., and alerting, if you bypass the MSI, probably you bypass the ADR, but only in execution stage. There's like, if your code or your stager is noisy in terms of behavior, like you are doing heavy process injection or something like that, okay, that's another problem with the ADR. You need to deal with it. But in terms of execution stage only, you can bypass the ADR as well if you bypass AMSI. So even we see here like non-malicious strings, we are trying to execute it and in the PowerShell instance without even loading it in memory. Like this function even not recognize functions, and we are just writing literally the string, and it's getting blocked by AMSI and reporting here in the ADR product as well, as we see. Here, Cobalt strike beacon, like we are trying to execute it, and the same issue, you got blocked by your antivirus. Like, you know, traditional AMSI, there's nothing fancy about it, this one. So another known bypass for AMSI, like using .NET reflection to override the value of a specific variable during the initialization of AMSI scanning engine. Okay, so we are setting the AMSI NF field to true. So whatever we are passing, it will just return AMSI result not detected. So easy bypass, but so noisy as well. So one other point is working only on the current session, and the bypass itself is detected, like AMSI trying to protect himself or itself from bypass attempts, like, well, why you are trying to turn me off, like something like that. So you need to obfuscate this code, by the way, heavily obfuscated, because it's really getting detected easily. Also, another trick you can use to bypass AMSI is patching the AMSI DDL. As we mentioned, AMSI just a DDL in terms of the elements header file, you're just including inside your project or whatever. You can just patch the function and make it always return, okay, this is not malicious code, whatever you are passing inside it. But there is some bad issues or some bad problems about patching the DDL. Like you can patch the DDL and drop it inside the directory and launch PowerShell instance from the same directory, and yeah, you bypass the MSI. Or if you are a local admin, you can just replace the DDL itself with an Windows 32-bit or Windows 32 directory, but it's a bit, you know, if you're a local admin, you can also just turn it off, but it's a bit noisy. Okay, so you can just replace the DDL. Another one is you can just patch the DDL in runtime, which is I'm not encouraging you to do if you are running with WNRM shell, because if you are in WNRM shell or Windows remoting, you are doing some sort of ladder movement or something like that, and you're just trying to patch the MSI during runtime, probably you lost your shell. And if you can't get the shell again, really don't do it, because it's a bad idea. So another way is just obfuscate your code, but using, who doesn't know, invoke obfuscation PowerShell code is really cool one. But let's say that you got really large code or tool set, okay, and you need to keep obfuscate your tools, so you want, you know, like you won't escape the static signature or something like that, an indicator of compromise within the environment while you are walking in and throwing your script right and left. Okay, so that's some kind of issue with invoke obfuscation, and this is not really something operational you can depend on during your engagement. During your engagement. Okay. So I released a tool called LightMe. It's basically a web server using invoke obfuscation tool and backend. Basically, you're just passing the directory of your tools or PowerShell scripts and start to obfuscate them in the background and serving the obfuscated scripts for you from that web server. Okay, and this is the result of running Cobalt Beacon from LightMe web server. Just the script got obfuscated, and we got our beacon here. Of course, interacting with Cobalt, if you want to, you know, stay undetected or something like that, you need to have really good profile within it. and which is not covered in this talk, unfortunately. Okay, but in order to bypass ADR and so on, interact with the target, you need to do that. Also, you can check some obfuscation technique from Delta Group repo on GitHub. Okay, I published some cool code obfuscation techniques you can use with PowerShell in case you want to obfuscate a script manually, or you want to do some cool stuff with it, like manual stuff for some small piece of scripts or something like that. So let's talk about fileless PowerShell malwares. Okay. PowerShell can execute a raw C# code, by the way, and interact with it. Like you are passing some raw PowerShell C# code or .NET code, and you are through add type, okay. And you can just interact with this class or the code you just injected into the PowerShell session from PowerShell itself. Like we got process howling code for here, for instance, here, right here, okay. And we are trying to inject the process howling code. We are passing the executable bytes to execute build function, which we are seeing here right on the right side of the slide, okay. And just calling the function from directly from the PowerShell. You can do the same method with process injection, for example. You can write some C# code, can perform some process injection or something like that. And you can also write your custom implement to bypass ADRs and so on. So you can also use some creative ways in order to deliver the bytecodes of the executable or the shell code itself, like scintigraphy or encryption or encoding or whatever you're gonna use. You can also use the same techniques for the raw code, because the raw code is like really, if you are using the raw code without obfuscation, you have a really big chance of getting detected from ADRs and just really general AV products. Okay. Also, another note: do not try to decode your executable bytes or your shell code within PowerShell code. Let all of the operation done inside the C# code, because if you try, for example, to exhaust the entire executable bytes, it's really gonna take a while within PowerShell. So I'm not encouraging you to do that. Just don't do that. You can do it within the C# code itself. Okay. Congratulations, you got your first initial access. You bypassed ADR and EMSI, of course, and live is good. That's what it looks like. You got a interpreter right here. Okay. As we see from process injection, like we run like get shell PS1 script, which is performing process injection, and it's pulled the shell code from our HTTP endpoint, and live looks really good. And everything seems fine, right? But no, I got bad news for you. It is not. Actually, ADR might fail to detect such attack. Okay, but really well configured sysmon and cool blue team guy can easily detect you. Not most of blue team guys thinking in that way, but think about the following. You are literally dropping the raw source code and the compiled binary into your target machine. So there is nothing literally fileless about this one, because actually you are dropping a file within temp directory. And another thing I want to mention about, if your code or your compiled code is already detected as or flagged as malicious, you will get, you want to get a shell already, because the ADR or AV product will simply catch you. Okay, so you can use this technique, but you really need to understand how the blue team, like the blue team on the other side, you need to understand which products they are using in order. For example, that protected event log trick, you need to understand if they are really skilled blue team guys, like can't really notice it. This one as well, like does they have really well configured sysmon or something like that? all of these indicators like helping you to understand or perform better red team operation. Okay, another thought about fileless malware. Fileless malware is equal invoker flexion B injection. If you don't know this tool is basically injecting B inside PowerShell process or a remote process. Okay, not the tool itself, but it's about the tool methodology. Okay, like just go and check the code, see how they are interacting with Windows APIs from PowerShell, and you can just start to write your implement or your PowerShell agent, like using just Windows APIs, and you're really not leaving too much behind to trace. Okay, not add type method because it's working. Okay, but I see it a bit stupid to use within environment has a really good blue team with well-configured sysmon or well-configured endpoint stuff. Okay, can just go and write your own Windows API calls within PowerShell and try to blow up shell from it, like through process injection or hallowing or whatever you think it's suitable for you. So what's stopping you from writing your implement in PowerShell? Because most of initial access cases are done with PowerShell. Like you're sending crafted macro, one click, you got your shell. Most of the time it's done through PowerShell, from my personal experience. And that's all for today. I'm gonna post code snippets mentioned during the presentation at my personal GitHub account. You can follow me on Twitter, safe_buffer. You can send me email for business or something like that, me@sweatyhell.com. Thank you guys.
Thank you very much, Hossam. It was a very beautiful and wonderful presentation. Evet chat, sorusu olan var mı? Sorusu varsa sana yönlendireceğim. If I see any question in the chat, I will be reading the question to you. Everybody says thank you and nice presentation. Yeah, thank you very much, Hossam.
Right, man.
Oh yeah, great. Herhangi bir sorunuz varsa arkadaşlar chat'e yazabilirsin. I think we have one question, Hussam.
Yeah, sure.
Disabling really work if we don't configure script block logging?
Don't get it.
Do you want me to repeat the question?
Yeah, like I don't get the question.
Yes, the question is disabling really work if you don't configure script block logging. It's kind of so. I think the question is if you
I don't understand the question.
if you don't configure script block logging, if it's gonna have some sort of effect on the PowerShell side. I think this is the question. So
no, okay. Script logging is not enabled by default within the Windows endpoints. Okay, they are configured or ensured by sort of group policies or manually by the system admins or something like that. But script block logging is not enabled by default in Windows, by the way.
Okay.
But more of the enterprise enabling it.
Yeah, great. So another question: does the bypass methods work in device guard lockdown systems with UMCI in place?
Was what? Couldn't hear you.
Okay, I'm gonna repeat the question one more time. Does these bypass methods work in device guard lockdown systems with UMCI in place? I don't know what is the UMCI, but the question is, I think, related to the device guard and the UMCI.
Device guard, depending on the configuration deployed within the endpoint, yeah, it's kind of working. Okay, unless you can access MS build executable and you can start it, and most of the cases you can interact with MS build executable within the environment. So yeah, it might work.
Okay, great. Chat, çok teşekkür ediyoruz Hüsam'a. You have a pool which has ended a minute ago. The options you have is burayı yıkarlar. What the fuck? bitsin zirvede bırakalım. And burayı yıkarlar has won the pool. So thank you very much, Hussam, for being in here. And it was wonderful to have you on the conference.
All right, man. Thank you. Have a nice day and have a nice